Hi everyone, it's Dr. Ahmed Mahmoud from the University of Leicester. Today I will be showing you how to collect training sample datasets for the machine learning automated change detection tool. So as you can see from the Google Earth Engine script that we have here and the machine learning ACD test for our new case study, we only have from the three main inputs. We do have the study area, the new study area, and we have a feature collection or a shapefile for the archaeological sites, which is called sites here. But as you know, there is a third input that we must define as well, which is the training sample datasets for the different land cover, land use classes that we have in our new case study. So to do so, we can refer to the training documentation, the EAMENA Machine Learning Automated Change Detection training documentation. And if you can scroll down to page number 9, you can see from the section of collecting training samples, there is different ways of collecting training samples. One of the ways is to collect the training samples using the geometry tool in Google Earth Engine, which I will be showing you how to do that. And then the second option is to collect the training samples using Google Earth Pro. And also you can collect the training samples on the ground, so from field work or field surveys. So if we go back to collecting training samples using the geometry tool, this is what I will be showing you how to do it today. So as you know that training samples are quite important for the machine learning algorithm to train it on how to distinguish between the different land cover, land use types in our study area. So the first thing to do is you need to define or identify in your study area how many classes do you have in this specific area. So for example, because we are working in the study area of Lafakat, which is in east of Libya. So we know that there is what we identified are 3 classes. These classes are basically the urban areas, bare soil, and also vegetation. So we do have 3 classes, and these 3 classes we must collect training sample data sets for these 3 classes. So to use the geometry tool in Google Earth Engine, so as you know that on the Google Earth Engine here, we do have different tabs or icons that we can use to draw different shapes and polygons, for example. So we can select the draw a shape icon here, and then we can start. You're gonna see the different imports that geometry imports that you will have here. So once you click here, a new layer will be added to the geometry import layers. So if you click on the edit layer properties, then you can change the name of that layer. So for example, as I said, let's collect the training samples for the first class, which is bear. So I'm just going to call it bear. And I'm doing that because I have these classes here. So I have bear, urban, vegetation. So these are my training samples that I have defined on the script. So I must have 3 training sample datasets that belong to the same with the same names. So if I go back here, because I haven't finished from that one, so I will just click here on edit layer properties. I will the name is Bear, which is similar to the name that we have on the script. Then I will change the geometry type into feature collection, because it will be a collection of polygons, or it will be multiple polygons or different data set samples for the same class, which is bare soil. So one important thing to add here is that we must click on a property and add a new property, which is basically a new field. So we call that one, we give it a name, land cover, and we must give it this specific name, because this name is predefined within the script. So the first value, because we are saying we said we have three classes. So the first class must be given the value of 0. The second class will be given the value of 1, and then the third class will be given the value of 2, and so on. So always the first class start with 0. So I will give it the value of 0 here, and then this is just the color, which you can I've showed you how to copy these colors and use it within the script if you want as well. So if I press OK, now we have this bare shapefile or bare feature collection, and then we can start drawing on this high resolution satellite image of Google Earth engine or Google Earth. As you can see, so for example, if I click again here, so these pans, this was highlighted, and now if I click on it, it's highlighted back again. So I can either use the rectangle or shapefile or points, but because I want to collect polygons, which is what is recommended to collect training sample data sets, then I will just click on this one, and then I will start collecting my samples for bare soil. So for example, this is an example of bare soil. And because I know that my study area is just within this area here, so I will just be collecting different polygons for bare soil. So always try to avoid areas that will have overlap, for example, between vegetation and bare soil. Try to avoid areas that might be kind of classified as urban as well. So, for example, these areas here might be classified as urban due to the similarity in spectral signature and so on. So I will continue collecting my training samples. So try to also distribute the collected data across all of your study area, which will improve the accuracy of the trained model and the accuracy later on, the accuracy of the classification and so on. So I will try to at least collect, I don't know, maybe over 50 or 100 polygons, just to kind of allow the algorithm or the machine learning algorithm to learn quite a lot of the variations that you have for the specific class. So just for the sake of this video, I'm not gonna continue doing so, but I will change to the second class. So if we want to add the second class, which is what we have here, which is urban class, then I can just click on a new layer, and then I will click again on edit, and then I will change it to the change the name into urban. Again, I will give it feature collection, changing the geometry of this layer into feature collection, and then I will say property. I will give it a name, land cover, and then for the value, I will give it 1 because it's my second class. Then I will change the color for this one. Maybe I can give it this color, which I can copy, and then I can just press OK. I've copied the color. If I return back to the colors here on the script, I can change this color to the new color that I want, and so on. So you can also change the colors here so that you know exactly the colors that correspond to your different land cover, land use classes. So if I return back to my class here, the urban class, I clicked on the draw shape, and then I can start drawing on urban areas. So, and I can start collecting training samples. So try to also avoid any overlap. So for example, you can see that these are vegetation or trees, so that might also overlap between with the urban areas, because you have to always take into consideration that the spatial resolution for the Sentinel-2 will be 10-meter resolution. So definitely or probably there might be some overlap between these between these pixels here, and then some of them might be classified as incorrectly. So if I continue collecting training samples for urban areas, buildings, and so on. So this could include also highways and roads as well as part of the urban areas. I will continue again, as I said, try to distribute your collected training samples. One of the issues that you can see actually here is that there is some shadows here, which will actually generate some misclassification or some overlap between these buildings and vegetation as well. So you can see that there is also shadows here for trees. This is always a challenge, and that you have to be very careful when you collect your training samples, because this is what the machine learning model will learn in terms of defining or identifying this specific class. So because we are talking here about urban areas, so there is variation in terms of buildings. So try to also accommodate that as well in your training samples, rather than just collecting some samples from the same some same reflectance or some reflecting surfaces. So for example, you can see there is a significant variation considered or compared to the other buildings. So I'm not going to continue on this as well. So this is how you collect the data for the training samples for the second class, and then I can just add another layer, and then give it vegetation as my third class. Change the property into the geometry into feature collection, and then I will add a property which is land cover, and then the value would be 2, and then I can give it a green color. So I can say okay, and then I can again start collecting some data for samples for this class. So, for example, this is vegetation, this is trees. There is variation between vegetation cover in terms of it could be trees, it could be agricultural areas, it could be bushes. So it depends on your study area, and it depends on the classes that you have, and it depends on the specific application that you want to. But here, because we are interested in seeing areas that agricultural areas, for example, or green areas that expanded into heritage sites, so then we can train, for example, or on bushes or on trees, and then we can make sure that this is taken into consideration when training the model. So yeah, again, I'm gonna just stop here, and then it's recommended that you try to, as much as possible, to collect a larger number of training samples for your classes. The more you have, the better your machine learning algorithm would be. And actually, it's the more accurate collected samples, the more accurate the model will be. So now we have the three classes that we have, which we have defined here in our script there: dataset, urban, vegetation, and then now we can run the script with those results, with those training samples, and we can get results. So we can just click save to make sure that we have saved the imports that we did here. But what I'm quite certain of is that these training samples actually, because we trained it on or we collected it on this specific satellite image, which would probably be dated to 2025, for example. But if I'm doing some work in 2020 or 2017, then these training samples might not produce accurate results, because these locations, for example, I've collected training samples for vegetation here or for trees, but actually this area used to be bare soil, and it changed with time. So we have to be very careful. So what we can do now is that if we refer back to the training documentation, so I've showed you how to change and create these training samples on Google Earth Engine. So as I said, some tips for drawing these polygons: try to aim to capture several representation or representative examples of each class, variation in terms of the polygon sizes, and also the well-distributed polygons would also will ensure also the spatial representation of the training samples. I think so. One important thing that we need to also take into consideration is that, as I mentioned, these training samples are actually collected on a high-resolution satellite image, which is just the background of Google Earth Engine. But you need to improve the accuracy of these collected training samples. And what we can do is that we can export these training sample datasets and to kind of validate the location of these collected training datasets. So what we can do is that we can import to check for the accuracy, we can import these exported shapefile. So we can export these training samples, and I'm going to show you how to export them from Google Earth Engine. And then you can and then import them into Google Earth Pro. And then you can edit each polygon boundary through the properties option, which I will show you that in a minute. And then you can save and edit these datasets classes as a new KML. I'm going to show you these steps in a minute. So if we go back to the our script in Google Earth Engine, so now if I run the script, because I said I collected these training samples, so it's not accurate, but I know that these I know that the script will work, but it will not produce good good results. So if you can see now, once I click on run on the task tab here, the classes or the training sample data sets actually appeared on the task tab. So if I click, I can export them by clicking on each of them. So I can click run, and then I can export the bare soil or bare training samples, and it will be saved to my Google Drive and saved as a shapefile. So if I click run, then it will start doing the process. I will do this for all of my classes. So I already prepared these exported training samples data sets, which I do have here. So as the training documentation says, it says you can import it into Google Earth Pro. So I can come to Google Earth Pro, and then I can press open. And then if I go to my where I saved where I saved my data, which is basically here. So as you can see now, you can't see that drive. It says it's empty, but if I click on all files, then I can see the shapefile. So I can add the first one, which is the shapefile. So if I click on this one, and then I press open, I can say open it in Google Earth Pro. So it will open. If I click it here, it will appear. So these polygons here are the polygons that I collected for the bare soil in the area of Lafakat. So as I mentioned, if I want to train my machine learning model on the year of 2020, for example, then I can click here on the show historical imagery to look for historical images. So I can just try and move into images that were collected in 2020. So for example, this image was collected on, this is a very high resolution image collected in January 2020. It's actually in 19. So if I go back again, so this one was collected in March 2020. So I will, if you click here, you can see the specific date for your image. Yeah. So what you can do now is that once you are happy with the satellite images that you have too many images for that specific year that you want to train your model on, then you can click on. So if I click just on this one, so you will see that this polygon is actually says land cover 0. So which if you remember, I've predefined that on the geometry tool, and I gave bare soil or bare class. I gave it the value of 0. So if I want, for example, I want to remove this one, so I can just click and then I can say delete, right? So if I, for example, I find that this specific location wasn't bare soil at that time, or it was, yeah, it was part of a different class, then I can delete it. What I can do else is that, for example, I can change the boundary of a specific polygon as well. So if I click right click on this specific polygon, then I click on properties, and I can also change, and then I can change the extent of this polygon as well, and so on. So I can say, so for example, I think one more thing that we can do is that we can also, if you want to see the background, so you can click here, right click, and then properties, and then you can change the yeah, you can change the properties or the color for this specific polygon. I was planning to do that for all of them once, which is possible, but I'm just going to do it for now. For some reason, I can do it there. So you can change the properties here, and then you can say outline, and then you can see the background of the high resolution satellite image, and then it will allow you to make the edits much easier. So you have to do, so for example, for this image, you have to do this for all of the polygons, which is the tedious job. It takes a lot of time to edit these polygons. So this is one of the drawbacks of this method. And then you will just scroll on the other satellite images and try to make sure that all of the polygons that you have here are actually, they do belong to this specific class. One more thing that you can do, so you can do the same thing rather than doing it here in Google Earth, in Google Earth Pro, you can do it in QGIS. So once I'm happy with my training samples and the location of each one of these polygons, so I can just click right click on the folder here, and then I will say save places as, and then I will save it as KML. And then I will also save them, for example, in my folder, and then I will click save. So once I save it here, so it's the edited version of the training data set. Then I can open it in QGIS to convert it into shapefile. So I can just open QGIS. I will just go to layer. I will add the KML file. I will add the KML file, which is this one. Say add. I will add it. So this is my updated KML file, and if I open it here, you can see that I have on the attribute table, I have column that is named land cover, and these are the classes that I already gave it to it. And then I can just click right click, and then I can say save as, and I can export it as a shape file, and I give it a name, and then again I will save it also. In yeah, again I will save it in my folder. So once I do that, I will have the new shapefile. So I can go back, return back to Google Earth Engine. I will do the same thing actually for in Google Earth Pro. I will do that for the other classes, urban training data sets and vegetation training data set. I will add them to Google Earth Pro, and then I will use the historical imagery and do the verification here as well. And then I will export, save it as a camel, and then export it, import it into QGIS, open it, and then export it as a shape file. Once I have all of them, then I can return back to my Google Earth Engine account, and then I will click on Assets, then New Asset, and then I will click Save. Sorry, Upload source files. I will select the files that I updated. For example, I would say, let's just assume that I have updated these vegetation training data sets. So I will select all the files, shape files related to the updated vegetation training sample data set, and then I will say upload, and then once I click upload, it will start uploading the file or the new updated vegetation training samples, which will take some time. Once I have that, I can go back to my, I can just refresh, and then I will see the vegetation training samples here. So these are the old ones. So I can just delete them from my script because I know that they were not correct. So I can just add my new updated training samples. So that one for the bear, this one for the urban, and this one for the vegetation. And these are the corrected and updated training samples. So the first one is called bear. I will do that. The second one is called urban, and the third one is vegetation. So yeah, so now, so as you can see, so because I defined it here as vegetation with a small v, and then this one will not work. So I need to make sure that the name is actually the correct name. So this one is vegetation. So I can just click save, and then I can run the script, and it will work based on the updated and more accurate training data set. So this is how to collect the training samples using Google Earth Engine, using the geometry tool, and then verifying or validating the accuracy of those training samples in Google Earth Engine, or in very high resolution satellite images. You can do that as well in QGIS if you have very access to very high resolution satellite images. Which could be more accurate. So there is another way of doing that using Google Earth Pro, which you can just follow here, and it will be the same, similar to what we did with the geometry tool as well. As I mentioned, you can earlier as well, that you can collect training samples in the ground using differential GPS or GPS navigator to collect points or polygons that represent the different land cover classes that you want to define on the ground, and to classify your images that represent the study area. So that's everything for the collection of training sample data sets that is needed to prepare the machine learning ACD to analyze the satellite images to detect the changes and threats to heritage sites. Thank you very much.